Hello again, and today we're going to look at just a little refresher on trig. Now, I was a bit reluctant to add this to the algebra review, but I felt like it wouldn't hurt to add just a little bit. I'm not going to do much. I'm going to do one problem with the 6 trigonometric functions, but I think it's if you're taking this review, you're taking it for a reason, and chances are you're taking it to do better on a placement test. And if that's true, it wouldn't hurt for you to remember some of the things that are on the basic trig portion. Make sure you know the unit circle. Now, you can do this unit circle very easily if you know the 3 special angles. What are the 3 special angles? The 3 special angles are the 30-degree angle, the 45-degree angle, and the 60-degree angle, which is the 30-degree angle on its side. Now, again, this is just a review, so you should remember those angles. If you've had trig before, you should remember those angles. And if you can see, as you can see, here are the special angles, and the special angles rotate around, and I'll show you that in just a minute, because I'm not going to fill it out for you, but what I'm going to do is try to knock some of the cobwebs loose. We know that the largest number on a triangle, a right triangle, is the hypotenuse. So we know that 45 is real easy to remember, 1 square root of 2. Now, what is greater, the square root of 3 or the square or 2? Square root of 3 is 1.7. So this is the square root of 3, 2, 1, and then 1, square root of 3, and 2. Now, we're going to go over this part, and then you'll be able, this part right here, the 6 trigonometric functions. If you can do the 6 trigonometric functions and you can remember your special angles, then you can fill out your unit circle without memorizing it, because what is 90 plus 30? 90 plus 30 is 120. What is 90 plus 45? 135. What is 90 plus 60? 150. What's 180 plus 30? 210. What's 180 plus 45? 225. What's 180 plus 60? 240. What's 270 plus 30? 300. What's 270 plus 45? 315. And what's 270 plus 60? 330. And if you know those special angles down here, then you know that this is positive quadrant. You know this is negative positive quadrant. You know this is negative quadrant, and you know this is positive negative quadrant, so you know how they end up. I'm not going to spend a lot of time on that. I'm just going to do one problem with the 6 trigonometric functions. We'll do that on the next slide. And I just wanted you to be reminded of these basic identities. Those basic identities are the reciprocal identities, right here, the tangent and cotangent identities, and the Pythagorean identity. The Pythagorean theorem I'm going to go over on the next page when I do the 6 trigonometric functions. Now, again, when you look at these 3 things, or 4 things if you include what I did down at the bottom of the special angles, you should be saying to yourself, okay, I remember some of this now. I remember doing the special angles. I remember doing the unit circle. I remember doing the identities. Now, whether you remember them to master them or not, that's a different story, and that's not what I'm here for. I'm here to kind of jog the memory so when you see them on a test, you might know a little bit more than you knew before. On the next page, I've got one problem that I'll go ahead and pull up. And there is the problem. Now, first thing you got to do when you work one of these is you got to find the hypotenuse. The Pythagorean theorem states a squared plus b squared is equal to c squared, or c is equal to the square root of a squared plus b squared. So in this case, I'm going to take, here's a, doesn't matter which one because addition is commutative, so it really doesn't matter. A is 6 squared plus 8 squared, and 36 plus 64 is 100, and the square root of 100 is 10. So C is equal to 10. Now C is called the hypotenuse. The hypotenuse has several different distinctions about it. 1, it's always C. 2 is always the longest side. 3 is always across from the 90-degree angle. So the hypotenuse is, that's supposed to be an E-N, sorry. Hypotenuse. The hypotenuse, that don't look right. But anyway, the hypotenuse is always the longest side. It's always across from the 90-degree angle. And it's always C. Now, once I found the hypotenuse, now I can do the 6 trigonometric functions. And it's not going to cooperate. So, sine, and I do sine, cosine, tangent, cotangent, secant, cosecant. Oscar had a hunk of apple, apple of hunk A, and hypotenuse, or had Oscar. And of course, the cotangent is the reciprocal of the tangent, the secant is the reciprocal of the cosine, and the cosecant is the reciprocal of the sine. So it really doesn't matter how you remember them, whether it's Sakatoa or whether it's Oscar had a hunk of apple, I don't care. Now you just plug and chug. O. Now let's talk about O. What is O? Well, I always tell students when you're on the put your little man on the theta down here on the angle, and your little man will always have his foot on the adjacent and the hypotenuse. So that means that this guy over here, which is opposite from the angle you're trying to find, is the opposite. So Oscar is 8 over 10, 6 over 10, and 8 over 6. And of course you reduce as needed. 6 over 8, 10 over 6, and 10 over 8. Now reduce, that's going to be 4/5 and 3/5 and 4/3, 3/4, 6/10, which is going to be, 5/3 and 5/4. And these are your 6 trigonometric functions. Now, that should knock some of the cobwebs loose. Again, I'm only doing this video to kind of give you a little bit of remembrance or a little bit of review of something that you might have seen at the end of Algebra 3 or Algebra 2, and may give you a couple of more questions on the placement test or whatever you're studying for. Again, I'm going to take it back to that screen so you can leave it and pause the video and write all that down if you need it. I don't know why this is showing up. Sorry about these marks that just show up. Okay.